1, 2, 3. Okay. So I'm sorry for the delay for the previous one, Audrey. Today we're going to record some of the lessons that we have not been able to do online because of your personal circumstances. Okay, so this is what we had yesterday, and last time I think we already done up until exercises 3, which means that today we're going to exercises 4. Now, exercises 4 is going to be quite a new thing here, and we're going to see some of the concept that's going to be taken from the previous one. This is the first time that we are going to have deal with order other than 1. Okay. All in previous example, the order will be order 1. Now, before we go into the multiple order here, we'll need to get some idea that for all of the mathematical formulation here, the steps of doing it can be quite different depending on the circumstances. There is no magic pill that will be able to do all the atoms here. So vigilance and ability to recognize the problem is going to be very important. That's why different questions may seem to be unrelated, but in the end, we will make some generalizations later after we finish them here. Okay, now for the first time here, we're going to go with the first question. Why double accent here? Double dash of x equals to 0. Okay, now let's have them here. Okay. Why double dash of x is going to be 0. And we also have two other information that the zeroth and the first derivative of 0 is 1. Okay, now let's start with this one here. We know that the second derivative is 0. If we have only one derivative, clear item to get the original function will be to integrate them. So if we have d square y dx square equals to 0, okay, means we can find the dy dx as the integration of dy dx square dx. In this case, it's going to be integrated of here. That's going to be a constant number 1. Let's say C1. To find the first derivative, we are going to integrate the second derivative. Okay. And we're going to have an arbitrary constant. Okay. Now, how do you find the arbitrary constant here? We're going to find it by substituting the first derivative values. Okay. dy dx for x equals 0 is to be 1. Okay. In this case, actually, dy dx is going to be a constant everywhere. So we don't need to state that it is for 0. Hence, C1 is 1. Okay. Now, we now understand that y dash, okay, is simply going to be 1. It's not even x, it's just 1, a constant 1. Okay. So this is dy dx. So how do we find the y itself? We're going to do the second. Integration. So the y is going to be integration of dy dx. It's going to be integration of 1 dx, or it's going to be x plus a second value. Okay, so the integration of 1 dx, it is integration of dx itself, that's x plus c, of course. How to find the c2? Now we're going to put the second information. Okay. So y of 0 is going to be x plus c2 when x equals 0. That's going to be 1. So 0 plus c2 is 1. C2. Hence, C2 is 1. Therefore, y is going to be x plus 1. Okay, this is the case when we have the second derivative with nothing else. Okay. Conclusion from this is whenever we have the nth derivative, okay, we are going to integrate them step by step. Okay, we are going to find the arbitrary constant each time here. If we have the boundary condition or initial conditions, we will be able to find those constants until we get into the original function. We can repeat this process for larger derivatives of x. Let's say the third, fourth, or any number of derivatives, as long as we find out what is the value of the derivatives at a particular point, we can find always the constant. This is the question number 1.